All right, guys, so here is going to be the video of me working out your quiz review for tomorrow. Okay, so just taking a look at this, you can see it's not very long, but the first 12 are all about rules of exponents. So that's everything we did yesterday. You had a little homework to deal with that as well. So let's just take a look at this. Okay, so for this first one, and these will be very similar to what you'll see tomorrow on your quiz. So make sure you watch this, take note, see kind of the things that are going on here. So this first one is going to end up being rules of exponent. It's going to be like bases being multiplied. Now the thing that is the distractor here is you can see that you have x's, right? But then they also have the coefficients out in front. And by coefficients, I mean the numbers. So you've got this 8 and this 5. So looking at this, if you were going to work this out, before you can try and do the like products, you've got to do 8 times 5, which ends up being 40. And then with your x's, you've got to remember when they are like bases and you are multiplying, you add exponents, okay? The other trick to remember is when there is nothing with the x, it's really a 1. So here it turns into 1 plus 3. So you have 40 to the x 1 plus 3, which simplifies to 40x to the fourth. Okay, so that's how you work number one. Number two is very similar. Okay, again, you have the like bases with the ends. However, your exponent or your coefficients, are a little bit different. That is because there's nothing in front of the first end. Okay, that is again a number one. So when you work this out, 1 times 6 is 6. Then you have n squared times n squared. Well, that becomes n squared to the 2 plus 2. And when you simplify that, you get 6n to the fourth power. All right, so the big thing there is remembering when you have like bases, you should add exponents, right? Number three is a very similar type problem. You've got 6p times 4p. Well, the first thing you want to do is multiply the numbers that are out in front. So 6 times 4 becomes 24. Now, p's are the like bases, but the things you got to remember with both p's there, that means that the exponent is really 1 on each side. And when you multiply that, that becomes 1 plus 1, okay, because you add exponents when you multiply. So you get 24p squared. All right, so now on to number 4. Number 4 is another one. However, this time I tried to trick you because I give you 3 things. So you see that all 3 of them have an n. So you know you're going to end up, since we're multiplying, adding all of those exponents together. However, we've got to first multiply all the leading coefficients. So you have a 6, there's nothing there, so that's a 1, and then a 3. So the first thing you have to do is 6 times 1 times 3. And if you do that, you end up getting 18. Okay? Then your ends, you have to add all your exponents. So you've got a 3 plus a 3 plus a 2. And again, I got those from the exponents that are all with the n. Okay? So then to simplify that, you get 18n. 3 plus 3 is 6, plus 2 is 8. Okay? All right. Now, moving on here next, we have number 5. Okay, so looking at number 5. Number 5 is our first one where we are using division. And the thing to remember about exponents, when you divide, you will actually subtract them. Now, if you cannot get it to work out nicely with your fraction, do not make it a decimal, just leave it. So in this case, as you look at this, remember we are combining our ends, so that means we are actually subtracting them. So that means you have 8n to the fourth, but then there was 3 on the bottom, so it's really minus 3 over, well, if we take those out to the top because we're subtracting it, we're left with just a 7. Okay, so looking at that, when you simplify, 8n, 4 minus 3 is just 1 over 7. Okay, now I want to show you something and talk about this, all right? Does everybody see how I have n to the first? You do not actually have to write that, okay? So typically, you're just going to leave it as just n. So your final answer here would be 8n over 7, okay? Because you don't have to write 1 in the exponent power. All right, okay? Here is another example right here in number 6. Okay, another example where we are using division. So that means we need to subtract. Now, as I look at these, I see that there's no exponent. So I've got to remember that means they're both to the first power. So here, I will then end up with 3, 1, minus 1 from the bottom. Okay, because you always do top minus bottom, divided by 4. Well, that becomes 3 into the 0 over 4. Now, this is big because into the 0 is something special. Anything to the 0 power is just the number 1. So that means that this is no longer into the 0, but it is 1. So up top we have 3 times 1 over 4, which will reduce to 3 over 4. All right. So we'll keep working here. We've got a few more subtraction type problems, and hopefully you're noticing here that even when you have a number in the bottom, you can just leave that thing down. All right. The only thing that you're going to actually bring up is the stuff that goes with the exponent. Okay. So as I look at this one, I notice again I have p's in both places. So up top I have p to the 4th, but then it's going to be minus 3 because there was 3 p's on the bottom. But then I still have a 6 left down there. As I simplify that, 4 minus 3 is 1. So it's really p to the 1st, or just p, over 6. All right. As we keep this thing going, all right, good. Number 8's got a little bit, not really, it's just got an extra step. It's got something that you can reduce here, okay? But let's start like we've been starting. We've got p's in both, so I have 7p up top to the 4th. But there was 2 p's in the bottom, so I'm going to subtract 2 from that up top. And that leaves me with a 7 on the bottom, because that p squared was subtracted up top. So therefore, as you look at that, that means I have 7p squared over 7. Now, here's the part that is different. Now I have the same number on top and bottom of my fraction. Well, what we've got to remember is when the same number is on top and bottom, it will cancel out. And once it cancels out, it leaves you with just p squared. Okay, that's a reducing part. All right, so when we can, we try and reduce the fractions to get down to what we can, the smallest possible outcome. All right, now these last 4 have a little bit extra going on because you've got to do a couple things a little different. You have to work pieces first before you can move on to the second. So for example, on number 9, you've got 4r to the 3rd times 2r to the 3rd in parentheses raised to the 2nd power. Well, before you can multiply, you have to work out this parentheses first. It goes just in line with PEMDAS like we learned last week with integers. It's just building off the same thing. So the first thing I'm going to do is try and simplify that. Well, remember from our notes, when we do that, I'm just going to work this over here. You take that power, and it's got to go to every piece inside. So that means you're going to end up with a 2 squared, and you're going to end up with an r to the 3rd squared. But the big thing there is to remember, when you raise a power to a power, you should multiply. So it's really going to be r3 times 2. Okay? Then, looking at this, 2 squared becomes 4. R to the 3 times 2 becomes r to the 6. That means that over here in this problem, now we have 4r to the 3rd, because that was original, times 4r to the 6th. And now this is just like the problems we started with in the front. We've got the like bases of an r, but we need to multiply the coefficients out in front. So 4 times 4 becomes, and I'm going to write that right here, becomes 16. And then you're going to have r to the 3 times r to the 6. Well, that ends up being 3 plus 6, okay, because you want to add them. So you get 16r to the 9th. All right, a few more of these. All right, so still looking at number 10 right here. Number 10 is very similar. Before you get to this, you want to go ahead and do the power to a power. But you got to remember that 3 is going to go, whoops, still have the highlighter selected. that 3 is going to go to the 4 and to the n to the 4th. So that means you have 4 to the 3rd times n to the 4 times 3. All right. Now, if you work out 4 to the 3rd, all right, you just plug that into your calculator. That's how I would do it. It's really saying 4 times 4 times 4. You would get 64 into the 12th. Okay. How you get into the 12th? 4 times 3. That means now we have 64 into the 12th times into the 4th, which was from our original equation. We have 2 like bases here, and then the coefficients out in front are 64 and then 1 because nothing was in front of the n to the 4th. So you end up with 64 and then n to the 12 plus 4, which would reduce to 64 into the 16th. All right, so let's keep working here. Okay, another problem very similar to that right here on number 11. All right, so as I work at that, I've got 3x to the 4th raised to the 3rd power. Whoops, had the highlighter selected still again. Got to distribute it out. So I'm going to come over here to the side to work this. So that becomes 3 to the 3rd times x to the 4 times 3. Okay, so reducing that, 3 to the 3rd becomes 27. And then that becomes x to the 4 times 3, which is x to the 12th. So now you have 27x to the 12th times 3x to the 3rd. And again, we've got like bases with the x's, but we got to multiply the coefficients out in front. 27 times 3 becomes 81. Oh, 81, that is correct. Then your like bases, you're going to get x to the 12 plus 3 because you are adding them together. And you end up with 81x to the 15th. Okay. All right. And then the last problem, number 12, that is with the coefficients. Okay. Or excuse me, that is with the exponents. Same idea here. You've got another one, so you need to distribute that thing out. Now, this one ends up being a little bit easier. Okay. You end up with 3 to the 3rd again times b. Now, there's nothing with your b. What you have to remember is really b to the 1st then. So that becomes 1 times 3. All right. So 3 raised to the 3rd power becomes 27. b to the 1 times 3 becomes b to the 3rd. So now you've got 27 b to the 3rd times b to the 3rd. Well, we've got b's, so we know that we're going to have powers, okay? And then we're going to have coefficients out in front, 27 and 1. So that means we would get 27 b to the 3 plus 3 because you add them when you multiply. So it's 27 b to the 6th. All right, so now we're looking at number 13, and I'll go ahead and tell you tomorrow on your quiz. The one that works with these, it's going to be a matching deal, okay? So you're going to see a set of problems, and then off to the sides, you're going to have all of these definitions, and you've got to choose which one. So right here, I just ask you to write an example, okay? Sure, you could just choose if you wanted to do addition or multiplication, but tomorrow on the quiz, you are going to have to do both. So I'm going to write my example for both when it's applicable here. All right, so first thing right here is you have the distributive property. All right, so I've just got to make an example. All right, so my example is going to be very similar to what I did in my notes. It's going to be 7 times x plus y. So remember, to be the distributive property, you've got to take that 7 and distribute it to both, which would get you 7x plus 7y. Okay, so there's your example of the distributive property. All right, the next one is the commutative property. So I'm going to show you. I will do the addition in red. Okay, so my addition problem like this would be saying that you have 3 plus 5, and that has to equal 5 plus 3, because remember, commutative allows you to switch around the order. Similar to that, the commutative of multiplication, which I'll do right here in yellow, would be something like x times y is equal to y times x. There are two things being multiplied, and you can just switch their order around. All right, the associative property also has one. So remember, the associative property, as we have looked at it, has dealt with three things, but it could always be three or more things. And what it says is that you can switch around the order that you do things, and that works for addition and multiplication. So how I talk to you about it is, think about when you associate with people. You don't always associate with the same person. Sometimes you talk to one friend, sometimes you talk to other friends. Now, COVID times, we got to keep up with that, but right now that's kind of an easy way to think about it. So my example for addition here would be, you could have x plus y in parentheses and then add a 3 to it. But that is also the same thing as doing just an x, but adding to it a y plus 3 in parentheses, all right? Where you've got to work out that parentheses first from PEMDAS, but you would get the same answer, all right? That works very similarly to a multiplication one. Okay, you could have 5 times 3 in parentheses, then times 2. Well, that is the same as 5 times, and then in parentheses, 3 times 2. All right, you can see all we did was change the order and move them around. Okay, next we have the identity property. And the identity property is the property that simply says you can add or multiply a number by something and it doesn't change it. Okay, so when we think of the additive property or the additive identity property, the number that you can add to something that won't change it is 0. So for instance, we could say 22 plus 0 is still 22. That's because the identity property is something that you can just add that doesn't change anything. All right. Now, for multiplication, it's a different number. For multiplication, it's the number 1. So you could take 51, multiply it by 1, and it's not going to change it at all. It will leave it at 51. That's because it's the identity. It keeps it there. All right. Now, the next one is my favorite one because it is so easy. The multiplicative property of 0. Here is literally what it means. 0 times anything is, you're right, it's 0. So you can pick any number you want to in the world, any letter you want to in the world. If you multiply it by 0, it's 0. So I'm going to do it right here. Hey, if we do 3 times 0, it is 0. Works every single time. Doesn't matter, okay? All right, and then the last one is the inverse property. Again, this is one that has addition and multiplication with it. So the inverse property is essentially anything that undoes it. So we talk about inverses. It's the opposite. It basically, if you want to think about it, it undoes. So it takes you back to that identity property. So for addition, you're going to end up with a number. So I'll just say that number is 7, okay? Well, to get the inverse property of addition, you need to add to it the number that undoes that. Well, the opposite of 7 in addition is -7. And if you add that to it, you end up getting 0. You know you have done it right because now you are back at the identity property, the number that you can add to it that won't change it. All right, now, to finish this up, I'm going to give you 2 examples of multiplication ones. So the first is going to be with a whole number. So if I had the number 8, all right, to get to the identity property, all right, you've got to basically multiply it by the reciprocal. So 8 is really 8 over 1, so you would multiply it by 1 over 8, all right? Now, I just said it's really 8 over 1. Here's why. Watch what happens when we work this out. Up top, 8 times 1 is 8. On the bottom, 1 times 8 is 8. You get 8 over 8, which is 1. See how that also takes you back up here to the identity property that you multiplied by that didn't change anything. Now, the one I want to show you, and we had these on our homework and on our notes, which is just a little bit different. What if you had a fraction? What if you had, let's just say you had 2/3. Let's just keep it easy. All right. Well, what you would have to do here is if you wanted to use the inverse property on that, you'd have to multiply it by 3 over 2. because you got to multiply by the reciprocal. That just means you flip it. Well, up top, 2 times 3 is 6. On the bottom, 3 times 2 is 6. And 6 divided by 6 is 1. So notice any of those ways could work it out for you. All right. So there is the answer key for this. Again, this is me talking through it, kind of how I did it. Make sure you watch this, see it, and remember that you can use this tomorrow on your quiz. Y'all have a good day. I'll see y'all tomorrow.